Oh yes, we are doing this again. So all of derivatives, almost all of derivatives, need you to be able to subtract 1. And hopefully you want to do this quickly, so we're just going to practice subtracting 1. So I'm going to move this stuff around like I did last time. Let's do this one first. Oh, it's locked in. Let's do this one second. Let's do this one third. Let's do the positive fraction fourth. I don't know how I'm judging for space, but we'll do these two negative fractions at the end. Okay, so with each of these, subtract 1. Oops, not that. So 4 subtract 1, 3. Not so difficult. -1 subtract 1, -2. 0 subtract 1, -1. 5/9 subtract 1 is -4/9. Now I can do that quickly because what I am imagining happen in my head is that 1 is 9/9, so I have a common denominator. Subtract the tops, leave the denominator alone. So I'm just going to move this down a little bit so we can fit in this. And the reason I have 2 negative fractions is not because I think you need practice, even though you probably need practice. It's because I want you to be aware that if the negative is in the numerator and you subtract 1, or the negative is out front and you subtract 1, it's the same deal. So a negative means the fraction is negative. It doesn't matter if it's in the numerator. Doesn't matter if it's in the denominator. It doesn't matter if it's dead even out front. 1 negative is 1 negative. So when I do this question, I get -8/5. Oh, no, I don't. Yes, I do. So -3/5 subtract 5/5 for the common denominator is -8/5. And -10/3. So -7/3. See how my hand writes it like this. -3/3 is -10/3. So we're going to have to be able to do all of this stuff again in larger questions. Because today we're going to do the power of a function. I don't know why my stuff is a little bit off, but this dot should be right where my cursor is sitting. Okay, so with this, you can see that it's layered. So we take the derivative of the outside, meaning that we deal with this exponent 4 first. We repeat the bracket and then multiply it by the derivative of the inside of the bracket. So I call this outside-inside because we have to take care of 2 levels of derivatives, and we have to, dig out my red pen, multiply the level derivatives together. So what I've dug out is a visual that I personally use. You may find this completely ridiculous, but I see this. So I'm going to show you this quick little video, 2 minutes-ish. So I don't know if any of you have seen a Russian nesting doll before. I have one on the ledge in my classroom for this particular lesson. But a Russian nesting doll, obviously, now you know, has dolls inside dolls inside dolls. And this is actually what I think of when I do this kind of derivatives. Now, we're just doing it on 2 levels. It does get worse. So we deal with an outer casing and then move our way in. back to the note. So the brackets are the outer casing of our 2-level Russian doll. I hope I have enough room here, and I'm still going to use the blue that I did before. So everything is all set here because it's not multi-leveled. There's no letter fraction. So I am going to immediately take the derivative. So I have to tell you I'm going to take the derivative. So I have to take the derivative of the outside. So that means, just like before, I have to put the exponent down in front. As it says in my instructions, you repeat the bracket. Don't forget to make this one less. Then we multiply by the derivative of this stuff. So basically, you've thrown out the outer casing of the Russian doll, and all you're doing is looking at 3x plus 5. And the derivative of 3x plus 5 is 3 plus 0, so I'm just going to write down 3. Next thing you do is you find all your monomials. So by monomials, I mean, well, here's a monomial and here's a monomial. So you multiply them together. So that's a bad color scheme. Where the heck did my blue go? 12, and then repeat the bracket. And no, you never need to multiply this bracket out, as in you won't need to FOIL 3 times, and you're done. So that is the power of a function derivative. So as you can see here, maybe the notation will make sense to you now. To take the derivative of the entire function, you take the derivative of the outer function, leave the inner function alone, multiply by the derivative of the inner function. So that's what that says. So let's try it again with this one. It's a little more complicated. This time I'm going to snazz it up by using dy by dx. So I'm going to drop the 3 down in front. Keep writing. As in, don't change that bracket. But when you get to the end, oh, water alarm! I'm going to drink some water. Once you get to the end of the bracket, you must remember to subtract 1. Then multiply by, so I make a big deal about it by putting a dot, and then we take the derivative of this. So this is 5 minus, drop the 2 onto the 6, so that's 12x, and x to the 1. So this doesn't have any monomials to collect, so often you will see a textbook write it like this, which is no mathematical difference whatsoever. But you'll see the bracket that has the exponent at the back so that it's sort of descending. All right, next question. Next questions. Ooh, that looks nasty. So I'll use y prime for this. It's good to go. As opposed to this one, which is not good to go. So I'm going to drop the 3 down in front. Repeat the bracket. Make the bracket 1 less exponent. I'm going to forego the dot and just write the derivative of all these pieces. So 9x squared, 3 times 3 minus 1 on the exponent, minus 4x, 2 times 2 minus 1 on the exponent, plus 5 minus 0, because that's a constant, the end. So we are done that because there's no monomial. So like I said, a textbook may have this last bracket sitting between the 3 and the bracket that has the exponent. That there is no necessity to do that. So this is one of the times where I remember possibly saying, do you remember me saying that calculus has a problem in that you might have the right answer, but it looks different. So this could be a different look. So referring back to the last question, you might see an answer in the back of the book that looks like this or like this, and you've got to be able to tell the difference or ask me. All right, so that was a one-liner. Can you imagine doing this question by limits, putting in x plus h for every x, doing f at x plus h minus f at x over h and having to do limits. This is what we're avoiding by stealing the pattern of centuries ago with calculus. Next one is this one. So like I said, this one is not good to go. I'm actually going to use this space right here to make it good to go. So this is still y, because I'm not taking the derivative. I'm leaving the 2 in the numerator. I'm taking 1 minus x cubed, its bracket, and this is a 2 and this is a 1. So it's got an exponent 1/2, but because it came from the denominator, it's a negative 1/2. And now I can take the derivative. Fancy style. So 2 times the negative 1/2, that's dropping down because of the rule, is negative 1. And if you can't do that in your head, do it on your ABC button, but I hope that you can do that in your head. Keep writing the bracket, then minus 1 off of this, so that's negative 3 over 2, which I also hope that you can do in your head, multiplied by the derivative of this bracket. So the derivative of 1 is 0, which I'm not going to write down, and the derivative of negative x to the 3 is negative 3x squared. I do have monomials this time. I've got this one, and then I've also got a negative exponent. So I'm going to write this a bit differently. Negative 1 times negative 3 is positive 3 with its x squared in the numerator, and the negative exponent I'm going to put down in the denominator. And this is one of the answers you might see. You would not see the original line. That's not mathy enough. And you see my mistake. Can't talk and write at the same time. Now, another thing you may see, and this is an or option, meaning one or the other, is this 2 means we're taking the square root of 1 minus x cubed. And you can't put the little 3, as in this one right here, because then it'll be 33 or 9 or whatever. You'll have to put this 3 obviously outside, and that is another version. So I'm just going to write that here. Or. All right, now for a purpose. Holy smokes. So I'm going to write the original function, which is this. And you don't have a rule for this yet. This is actually a product, meaning you've got 2 pieces of information with x's in them, and you're multiplying them together. So you don't have any rules for that yet, and you don't have the exponent deal, so you don't have the outside inside. So I'm just going to FOIL this out. And yeah, this is your only choice at this point. And hopefully you see that this stuff is building. So if you didn't understand or get your problem straightened out from the first lesson, this one you may struggle with. So it does build. So these are all still y, hence my choice of black ink. And now I'm going to take the derivative. So I'm going to take the derivative here. Basically, in calculus, if you take the derivative, you're on the right track. So 30x, 15 times 2, and then minus 1 is x to the 1, plus 1 from the x minus 0. So I'm just going to leave it like that. And you should be comfortable with the first question here, which is to determine the equation of the tangent line at -1 and 3. So I'm going to do this here. So I'll have an m in a minute. I do have an x of -1, and I do have a y of 3. So this is an x, and this is a y. When we get to it, picking my color combination, when we get to it, this will be an x and this will be a y still. But let's take our time. So we still need this m. So I am going to take this, which is the derivative, which is m tan. So I'm being asked for the equation of the tangent line, so I'm finding the slope of the tangent line. And I'm putting -1, the x value, in for the x, and doing the math. Oh, I'm doing 2 maths at once. That happens to me often. So negative 30 plus 1 is negative 29. So I'm going to place that information here. And then I'm going to do my y equals mx plus b. Stop rushing. Maybe I'm not fantastic at 9 o'clock in the morning when I'm on vacation. So 3 for the y. Negative 29 times negative 1 for the mx plus b. 3 minus the 29 from the other side equals positive b. So that's negative 26 equals b. So in these questions, don't be surprised if you get some fairly gigantic positive or negative numbers. It's just a question. So therefore, the equation of the tangent, which is a line, so I'm going to put tangent line, is y equals mx plus b. The end. So I'm just going to take a little break because my hand is cramping up, and I'll be back with you in a sec. Okay, so equation of the tangent line I moved down below. If you ever print off this note, I think I'll have rearranged it in order. But the next question is to determine the equation of the normal line. Now, you might not know what a normal line is. And a normal line, all that is a line perpendicular to the tangent. So basically, if you have a curve and you have a line that is the tangent line at a certain specific spot, your normal will cut through that exact same spot, but at 90 degrees to the original tangent. So that means that we have to do the slope, and it's got to be the negative reciprocal. So your negative reciprocal after you find the slope. So I am about to take the x equals 3 and plug it in here. So I am actually finding m tan at a different spot. So instead of negative 1, I'm finding x equals negative 1. I'm finding it at x equals 3. So that ends up being a giant number of 91. So this is the m tan. So when I go to generate my my little list off to the side, my m, my x, and my y, I don't want the slope of the tangent because I need the slope of the normal. So I have to take the negative reciprocal of 91. So the reciprocal of 91, so this is m norm, the reciprocal of 91 is 1 over 91, and the negative reciprocal means that I have to have the opposite sign. So if this was negative, this would be positive. Because this is positive, this one's negative. My x, easy to find, is the 3. My y, easy to find, is the negative 4, because I gave this to you up here. So this part here was part A, and this part here is part B, and it leads you to an extra little step. And now we can go on and do y equals mx plus b. I'm going to shove this down so it's not in my vision. And carry on like normal. So y equals mx plus b. Y is negative 4. M is negative 1 over 91 times x, which is 3, plus b. So that's negative 3 over 91 plus b. Just going to shoot up here. negative 4 plus 3 over 91 equals b. So if I'm doing this quickly, that's negative 3 and 88 over 91, which is a mixed fraction, and I can't use a mixed fraction. So I actually have to figure out negative 3 and 88 over 91 as a improper fraction. So I need my calculator for that. So 3 times 91 equals plus 88 equals, so that's negative 361 over 91. All right, so therefore, y equals negative 3 over 91 x minus 361 over 91. That is the equation of the normal. I didn't make up that word. I'm going to move this down because I want to play with two things. I want to play with our equation of the tangent line, and I want to play with the equation of the normal line, but I need some space. And this is sort of grade 9-ish stuff. I want you to know that there are some alternate answers to this, and I'm sure you're aware of that anyhow. So, for instance, in this one of the alternate answers, because it's got a common denominator of 91, is you could take both parts of the fraction and put it over 91. So that is still y equals mx plus b. Another thing that could happen is that you could fling your 91 up here by multiplying both sides by it, and this typically is not an answer. But what is an answer is standard form. So this is general form, y equals mx plus b. Standard form looks in one of two ways. So number one, you pull everything to the x positive side. So that means I have to pull everything in this question to the left. And you can write it like this. Or you can write it like this. So this is one answer, this is another answer, this is another answer, this is another answer. So when you're looking in the back of the book to check your answers, you may get a variety of different looking answers, but they are all mathematically the same. I will specify whether I want general form or standard form. In this question, it's a little bit easier because it's lacking the fraction. So back to the tangent line, just to give you a different form. My x is negative on the right-hand side, so I'm going to pull everything to the left. So another form could be positive 29x plus the y equals, leave the 3 behind, or positive 29x plus the y minus the 3 equals 0. So this one has 3 potential answers, depending on what you're asked for. Now, if I go back to the original question, in this one, it says determine the equation of the tangent line, determine the equation of the normal line, and it doesn't tell you specifically how to find it, as in which form to give it in. So I personally would give it in y equals mx plus b because I get there quicker. So that is just a little aside. Here is the work out of the Calculus and Vectors textbook, and I guess I'm done lesson 2. This is amazing. I will be back at you with some more derivative rules. Yeah, there's more. They're never ending. I probably don't know all of them because I didn't go far enough in math. So, the end.